Just start hook. So today we will going to discuss another method of determination of polymer viscosity for the measurement of molar mass. So today we will going to discuss viscosity for the measurement of molar mass of polymeric substances. So now বললাম না ক্লাসটা শুরু করবো আর একজন একজন করে আসতে থাকবে। So what is viscosity? Suppose a fluid capable of flowing in a set of infinitesimally thin layers be placed between two rigid parallel planes, suppose of area A. Now, let a shear force Fs, such as, let me draw the diagram, then it will be much easier for you to understand. Just a minute. So, just let me draw the diagram. Now, if it is c-axis, this is maybe the x-axis, z, y. So what we can say that a plane okay, a plane. So suppose this is a plane and the cross sectional area is a. So if infinitesimally small thin layers of liquids are flowing, infinitesimally small liquids are flowing through the layer, so what we can have, we can say that a, suppose, so due to the force, this displacement is maybe v and the force is fs. Okay, so by definition what we can say, that by definition you can say the viscosity coefficient is actually stress by shear strain. Shear stress by shear strain. So, what is the stress? Stress equals to force by area. We know that. Strain equals to del V by del Y. Okay, it's a simple thing. This is equation 1. Okay, now this is equation 1. Now the viscosity may be expressed the viscosity may be expressed in terms of rate of shear energy. Actually, that is dissipated per unit volume of the field. Per unit volume of the field. This follows relation that from the relation I can write F by A into del V by del Y. I can write it F by A del V. I can write del X by del T displacement, or we can write or we can write it by a little bit of adjustment, that F del X by del T. So equivalently it can be it actually equivalent লেখাই উচিত. Equivalently it can be written for এটা তো del u by del T at V. Again, del u by del V by del T, del u by del V del T, that is del W by del T. Sorry, this is the main relation or actual relation that আরে বাবা, এটা ক্যাপিটাল W দিয়ে লেখার নিয়ম. এটা equation 2, where del W is the energy dissipated per unit volume. Dissipated per unit volume. Okay, so equation 1, we can write equation 1 how কিভাবে লেখা যেতে পারে? Equation 1 can be written as F by A del Y. Now multiplying both sides multiplying both sides by del V del Y, we get, suppose F by A আর এদিকে now it is by using equation 2 we can write this is equation 3. By using equation 2 we can write this. Now equation 1 and equation 3, this is the important part. That's why I'm developing the total relation here. Now equation 1 and 3 require velocity gradient is uniform. It is actually uniform throughout the liquid. Since this may not be case over microscopic distance, so we write equation 1 and 3 for infinitesimal distance. For infinitesimal distance, how we can write? We can write that eta equals to so this is the equation 4. So now we are coming to viscosity of a dilute solution involving spherical solute. I'm going step by step. এর এতক্ষণে অঙ্কুর So viscosity of a dilute solution involving spherical solute. So for dilute solution involving spherical solute, their shares the shear force required to impart the potential gradient is identical to that of the pure solvent is found to be greater than that the required for the pure solvent. Okay, আমি কথাটা একটু শর্ট ফর্মে লিখে দিচ্ছি যে আমরা কন্ডিশনগুলি কি কি, that what condition that I have considered, that the condition that I have considered that for a dilute solution involving spherical solute, for dilute solution involving spherical solute, the shear force required to impart the potential gradient identical to that or this statement is very important, for pure solvent is found to be greater than that required for the pure solvent. And we can write it like that, the shear force, we can write it, the shear force of solution equals to shear force of solvent divided by 1 minus sigma, where sigma,
Sorry, Rama, phi.
oh yes, phi, yes, this is the phi. The phi is the volume fraction of solute particles. Also solute particles in solution. So for a solution we can write, that viscosity coefficient of solution equals to shear force of solution by cross-sectional area of the surface by del V del Y. From there, by using the relation, this is actually equation 5, equation 4 that I have given, this is actually equation 5. So the solution that A by del V del Y, I can write it by using the relation pi. This is solvent by A del Y 1 minus 5. Okay, so this is the equation 6. Since we know that volume fraction is smaller than 1, as definitely should be smaller than 1 because it's a fraction, it's not the total volume. So I can say eta of solution is greater than eta of solvent. So eta of solution is greater than eta of solvent. From there, a minute. হ্যালো, হ্যাঁ হ্যাঁ বলছি। আচ্ছা, এই জোসনা অ্যাপার্টমেন্টের পাশে দেখবেন একটা ওই টায়ারের দোকান আছে, এটা সুস্তি সুস্তি টায়ার। এটা একটু পরে ওই তীর্থময়ী অ্যালুমিনিয়ামের পাশ দিয়ে যে গলিটা ঢুকছে সোজা বাড়িটা। না, বাড়িতে লোক আছে, আপনি গিয়ে করতে যেতে পারবেন। হ্যাঁ, একদম সোজা বাড়িটা। ঠিক আছে। হ্যাঁ, so okay, so now the more involved consideration, the more involved consideration of individual spherical particles of solute requires the addition of one more term in equation 6. One more term in equation 6, that is in this equation. So the modified expression I can write so the modified expression The modified expression is that what we can write, eta solution equals to eta solvent by eta 1.5. So this is the relation that we can develop from there. So this is the relation that we can develop from there. Okay, so this is our equation 7. Now the alternative form of equation 7, form of equation 7, definitely alternative form of equation 7 is obtained by the following replacement are very important, by the following replacement. So what is the replacement? I am going to replace one series solution as 1 plus phi plus phi square plus dot dot dot. It's an infinity series. So as it is an infinity series, I can say that solution is equals to 1 plus 0.5 pi, and the series I have put in the series there of solvent. So now multiplying the equation, multiplying the both the terms, 1 plus 2.5 phi plus 4 phi square. This equation 8, this equation 8 that I have, this equation 8, just a minute. Just a minute. Okay. So this equation 8 is known as Einstein's equation. As Einstein equation of for Einstein equation for the viscosity of a solution. So this equation 8 is known as Einstein equation for the viscosity of a solution. And this Einstein equation is very important for determination of the molecular mass of polymer. If you can develop up to this, the later but remaining part is not very complicated. So viscosity of a polymer solution. Now, while dealing with a polymer solution, the solute concentration is usually expressed in terms of mass per unit volume. Solute concentration is expressed in mass per unit volume. So if it is mass per unit volume, we can express volume fraction of the solute in terms of mass per unit volume of solution. So we can express of solute in terms mass per unit volume of solution. How we can express it? Pi equals to, that is partial molar volume. PM means partial molar volume, that is N1 by V1 PM plus N2 V2 PM. So this is equation 9, which is nothing but I have written phi in terms of partial molar volume. So number of mole into partial molar volume of V2 So for dilute solution, this is simplified as for dilute solution, this is simplified as এটাকে নেগলেক্ট করে দিই একবারে, জাস্ট এ মিনিট। As I am considering the dilute solution, M2, okay, where V is the volume of the solution. Now we can write এটা এটা তো হবে equation 10, M2 by V, it is C. Now substituting equation 10 in equation 8. Now substituting equation 10 in equation 8, we get that is 1 plus just a minute. So series I have put the value of phi there, that is put the value of series there. So n solvent, this is the solvent, so this is equation 11. Now the above expression is a special case that what we can write as eta equals to eta 0 for suppose b c2 plus c c2 square plus dot dot dot, that is equation 12, that what we can write, where b and c are determined by fitting experimental data on variation of viscosity, and eta 0 is the viscosity of the pure solvent. So that's how we can calculate the viscosity, that is the term C from the equation. Eta 0 is the viscosity of the pure solvent. So this is up to now that we have calculated the viscosity, and by using viscosity coefficient, by using viscosity coefficient we have calculated the concentration, and from the concentration we can calculate easily the molar mass of the solution, molar mass of the polymer solute. ঠিক আছে, বোঝা গেল? দিস ইজ ভিসকোসিটি মেথড। দুটো মেথডই পড়বো, একটা গতদিন অসমোটিক প্রেসার পড়লাম, আর একটা ভিসকোসিটি মেথড আজকে এখানে পড়লাম। ওকে, বোঝা গেল কথাটা? ইজ ইট ক্লিয়ার টু ইউ অল?
Yes, sir.
ওকে, থ্যাংক ইউ। জাস্ট ওয়েট এ মিনিট, রোল কলটা করে নিই। অপূর্ব, আইরি,
Yes, sir.
রাজেশ,
Yes, sir.
তন্ময়, বিজয়, সানুকি, তাহের, অম্লান, দীপজ্যোতি, হরিপদ, দীপ্তনু,
Sir,
আছে আছে, মামকি,
present, sir.
বিপ্লব,
Sir, Omlano আছে। Sir,
অম্লানও আছে, বিপ্লব,
Sir.
উদয় ভানু, সঙ্গীতা আছে,
Sir.
সাগরিকা আছে,
yes, sir.
সঞ্জয় আছে, সুমেন, সুমেন নাই, আজ পাঙ্কি আছে, অঙ্কুর, বনশ্রী।
Yes, sir.
ঠিক আছে,
Present, sir.
Sir, Uday.
হ্যাঁ
Uday, sir.
হ্যাঁ দিয়েছি।